Hey guys, yeah, it's me again. So back in the studio, and today we're gonna be doing a linear optimization mix, and it's gonna be the same problem that I've done using Maple and Wolfram Mathematica. So I'm just gonna do it using SymPy this time. Okay, just to show you that obviously you can solve problems with different software. Sorry. Okay, cool. So yeah, on a side note, guys, I'd really appreciate it if you do subscribe to my channel. So if you like what you see, please subscribe. Please share the videos with your friends, and yeah. I would greatly appreciate that. Okay, cool. So let's get started. So from then sympy dot solvers, right, dot simplex, right. So import lpmin, lpmin and lpmax, right. Okay, and then from sympy again, import star var variables, so x and sorry y, right. So there's variables. Okay, and so yeah, I'm gonna obviously um, assign um, assign my functions to variables as well. So m will be my objective function. So 5 times x, right. Sorry, if I could type. Yeah. So 2 times y, right. And then a will be so 3 times x, yeah, plus y is greater than or equal to 10, equal to 12. B will be 2 times x, right, plus y, right, is greater than or equal to 10. And then C will be 2 times x minus y is less than or equal to 15, right. So we want to minimize this function, objective function, right. So lpmin, right. So m as objective function as well, and then my constraints. So put a square bracket. So a and b and c, right. So my x, sorry, my cost of assignment is 22, and then my x is 2 and my y is 6. So if I substitute that into the objective function, so 5 times 2 is 10, and then 2 times 6 is 12, so 10 plus 12, 22, right. Bravo, right. And then I want to plot the feasible region, so I'm going to use plot implicit. So plot and implicit, okay, and actually Boolean stuff, right. So ABC, right. And then my ranges, so x will be minus 10 to 15, and then y would take the same as well, minus 10 to 15, right. Okay, so let's see. So there you are. So that's the plot. Okay. So that's the feasible region. Yeah. To the problem. Okay. Right. And then I can also plot it in a different way as well. I can right, do it this way. So expression equals a and b and c. Yeah, c, right. And then so plot plot implicit, expression, right. And then I'll just put the ranges. I'll just copy this. So copy that. So go on, copy, and yeah, paste that in there, right. It's a different way of doing it, right. So there we are. Okay, so that's my feasible region to the problem. Okay, So yeah, it was just another vid doing an optimization problem using Python, and yeah, so I've done one with Mathematica and one with Maple. So I'll put the links into the comments, and yeah. So if you like what you see again, guys, please do subscribe and please do share the videos with your friends. I would greatly appreciate that. Okay, cool. So bravo. Right. So I'm just gonna close that. Right. Okay. So comment. So thanks for watching, and please do subscribe. Right. Smiley face. Bravo. Cool. Cheers. Bye bye.